ओजोन ओजोन है, O3 है, यस। ऑक्सीजन आप जानते हैं, O एटम, molecule is O2, O3. This is an oxygen atom, we can also call it a nascent oxygen, free radical है, not very stable. Oxygen gas, stable, no problem. Ozone is also a gas, stable, no problem. What is the role? Oxygen. Oxygen का रोल है आपका कीपिंग ऑल लाइफ ओवर देयर, सो रेस्पिरेशन, वी नीड दैट, कंबशन, और मैं तो कहूंगा ओजोन के लिए भी ऑक्सीजन चाहिए। कैन बी मल्टीपल रोल्स, बट कंबशन, रेस्पिरेशन, दैट्स वेयर वी नीड ऑक्सीजन, लाइफ के लिए चाहिए। ओजोन के लिए कहाँ चाहिए? ओजोन कहाँ चाहिए? यूवी प्रोटेक्शन, यू नो, यूवी प्रोटेक्शन के लिए चाहिए। कहाँ पर होता है? स्ट्रेटोस्फीयर। स्ट्रेटोस्फीयर में देयर इज अ लेयर कॉल्ड ओजोनोस्फीयर, अराउंड 20 to 35 किलोमीटर्स की हाइट पर मैक्सिमम थिकनेस है इसका। ओजोन इन स्ट्रेटोस्फीयर, protective cover, protection against harmful ultraviolet radiations. Ozone in troposphere, this is called low level ozone. This is a pollutant, this is not desirable, this is a pollutant, it is a secondary pollutant. Pollutants are of two types, people who don't know. Primary pollutant, say for example you burn wood, directly it turns into carbon dioxide, that's a primary pollutant, yes. However, if a primary pollutant undergoes some special reactions, photochemical reactions, and it becomes something else, that is called a secondary pollutant. So vehicular exhaust, the exhaust coming from vehicles, undergoes chemical transformation and can turn into ozone. Ozone in the lower atmosphere is a pollutant, it is a strong bleaching agent, it is a strong oxidizing agent, it can cause tissue damage, it can also cause the pigment damage, the chlorophyll gets damaged in the plants. So plants lose their pigments, bleaching happens, tissue damage can happen, oxidation can happen. So ozone is a problem at the tropospheric level. But stratosphere, it is required, it is a very important protective cover. Get that? How is it formed? It is a photochemical reaction. It is a photochemical reaction. Oxygen in stratosphere plus oxygen, nascent oxygen in stratosphere, in the presence of sunlight, it is photochemical, means sunlight, turns into ozone. This is a reversible reaction. When ultraviolet rays falls on it, ozone gets disintegrated, it comes back to this also. This is a reversible reaction. So ozone keeps on forming and going depending upon the sunlight. So it has variable thickness. It has variable thickness. So when the photochemical reaction is on, it will become thicker, 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 and when it is not there, it will become thinner, 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 thicker, thinner. We don't get to see it because we are a tropical country. All the time sunlight is there, day and night. At night the sunlight is not there, so what will happen? It will reduce. But think about poles which have 6 months day and 6 months night. So if 6 months night, that means you can imagine no ozone forming. That is the time when it thins, 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 and can come to its thinnest level. And during the summers it comes back to the thicker level. So this is what ozone is there. You measure it in something called as Dobson unit. Its thickness is measured in Dobson units. I think 100 du is equal to 1 millimeter thick layer. That is what I remember. I read something in science classes in my school at that point in time. So this was ozone, which I had to talk, which you can check from basic science lectures anywhere. The issue that we are going to talk about is ozone depletion, the concerns in that, and ozone hole. Ozone depletion and ozone स्टोरी से शुरू करेंगे, थोड़ा ज्योग्राफी भी बनाते. This is Earth. Get that? This is the atmosphere. This green line is the tropopause. This green line is the tropopause. Remember, tropopause is higher at equator, 16 kilometers, lower at pole. और उसके बाद क्या है? उसके बाद है ओजोन. This is stratosphere. So ozone. Ozone. What is this? This is troposphere. And what is this? Stratosphere. And in between, pause. Is everyone okay? Since childhood, I have been told that ozone is very important. Ozone protects us from harmful UV radiations. So from the sunrise or from the sunlight or solar insolation spectrum, solar insolation, sun rays which are coming us, solar insolation spectrum, one of the component is ultraviolet radiations. These are very, very dangerous. They are penetrative, and what I was told is that they can cause cancer, particularly skin cancer. So sunburn happens, and after sunburn it goes to the level skin cancer. It can cause DNA mutations. It can cause cataract in the eye. But the most relatable thing which I since childhood knew was skin cancer means UV radiation. So it really went in me in my childhood days. Get that? Oh, perfectly okay. This is what the nature has done, and I told you that ozone layer is created as a part of the photochemical reaction, and it keeps on naturally. Somebody said ki ozone is destroyed naturally. No, it is not destroyed naturally. I am saying naturally its extent, its thickness varies. Why does it vary? Because the rate of formation and rate of destruction, it's a reversible reaction, photochemical reaction. Depending upon that, naturally it thickens and thins down, thickens and thins down. It doesn't get degraded. Thickens and thinning, that happens. Okay. Now, let me add the story further. So the story is of South America. Story is of a place called one is Punta de Arenas. Punta de Arenas. Or Punta Arenas. So if you remember that there was an island at the bottom of South America, if you attended my world geography classes, yes, Terra del Fuego. On that island is this settlement called Punta Arenas. This at that time was the southernmost inhabited settlement in the world. Now it is Ushuaia, but at that time Punta Arenas was there. Now Punta Arenas started reporting cases of skin cancer. When? In 1970s. Skin cancer. So when skin cancer comes, remember as a child I was very, very amazed by that skin cancer. Oh, skin cancer means UV radiations. So what is happening in Punta Arenas? UV radiations are there. They tested, they found yes, UV radiations, that amount is higher. Now comes the question, how come it will be higher? Because UV radiations come only through sunlight, and there is a protection. And they found for the first time that the ozone layer here was missing. or had thinned down. Do we get that? This part of ozone is thinning. This is ozone depletion. So thinning is called depletion, and when it thins to such an extent that it is almost absent, what is that called? Ozone hole. To their surprise, they found yes, ozone is depleting. When I am talking about in 1970s. ठीक है, हो जाता है यार. कोरोना हो गया तो कोरोना होने से क्या हुआ? चाइना में हुआ, दुनिया में पहुंचने में टाइम लगा. So the news came and nobody lives over there. A few people, a small settlement, Punta Arenas, they are over there. So the world was aware that there is some problem. ठीक है, let's forget that. So the scientists are aware of that, and scientists are wondering why it is happening. So now there, a group of students, not in Punta Arenas, they approached their professor and they asked him, sir, we want to do a PhD. What subject do we take? Okay? So it is not like India wali PhD. India wali PhD में आप कितना गाइड के आगे पीछे हाथ जोड़ के घूम सकते हैं, गाइड कितना फुटेज लेगा, that's a different story. आपने से बहुत से लोग PhD कर भी गए, आपने you've seen what it takes. ऐसा कोई ओरिजिनल रिसर्च नहीं हो रहा है. अगर ओरिजिनल रिसर्च होता तो बात ही क्या थी, बहुत सारे पेटेंट्स आते इंडिया के पास. सो ओरिजिनल रिसर्च नहीं होता, गाइड थिंग्स, एंड गाइड को भी तो लोग चाहिए. सो PhD हो रहा है. बट देयर these people went to their professor and they asked him, sir, we want to do our PhD, what should we take? And the professor said, let's take issues which are pertaining to the world, for which the world has no answers. That is what PhD is all about. They said, recently I heard something about ozone level being low, and because of that ultraviolet radiations coming in. Do research on that. So they said, sir, please tell us more about it. He said, I don't know much. You do it and we will discuss. We'll keep on discussing. Maybe we come to a solution. So this is how a PhD begins. So the story has that some place in the world is showing skin cancer, and somewhere in the world, in the developed world, there are people, there are students who have taken on a PhD on this subject. Get that? Now, let's forget these people in Punta the Arena. Let's go to these students. So these students went to check the samples, and they didn't know much about ozone. They were like you are beginners on ozone. So they studied ozone and they found oxygen plus nascent oxygen, photochemical reaction turns into ozone. They were happy. Then they went to the research station in southern hemisphere, some Antarctica reports, because Antarctica has research stations. They called for their reports. What is the level of ozone over there? So what did the report show? Let us see what was the graph of the report. The report showed something like this. The annual ozone layer graph. So there were highs, there were lows, and what is this? This is the thickness of ozone. So sometimes very thick and sometimes thin, thick. So they asked, why is this fluctuation in the graph? So they were told, see, ozone is a photochemical reaction, 6 months night. So when it is night, what happens? The ozone formation is less, and when it is day, remember 6 months daylight, so ozone is high. They said, okay, perfectly okay, high and low. They said, what happened here? This has gone to 0. They said, no, what is this? Machine error. ऐसा थोड़ी है कि ozone will become 0, machine में error हो गया होगा. Now if it was an Indian PhD student, गुरुजी ने कहा मान लेगा, but यहाँ तो original है. They said, no, it can't be machine error. Now to we are looking at cases. So maybe this was true. So now comes the question, if this has gone down, then what? Get that? Research is going on. 70s this issue is there, 80s the research is going on, and the world is also taking note of skin cancer, UV rays, ozone depletion. So the world is also noting. Now world is concerned. 1985. UN convenes a convention. This is called the Vienna Convention. Vienna Convention on Ozone. And they said that ozone is depleting. Now there is data. ये graph है हमारे पास. Ozone layer is depleting. So all members said, okay, yeah, it is depleting. Who are the members? Everyone in the world. Remember, developed countries call this meeting, and developing world they reach for chai, samosa, picnic. So Vienna गया यार, क्या चाहिए और Vienna घूमने पहुंचा. तो उन्हें बताया ओजोन डिप्लीट हो रहा है. उनसे पूछो व्हाट इज ओजोन, उन्हें कुछ नहीं पता. डेवलपिंग वर्ल्ड मजे में बैठा है यार, खा रहा है. तो ओजोन इज डिप्लीटिंग. सेकंड, it is dangerous because UV rays are entering. Okay, that's also fine. Third thing, let us pledge, commit to take all actions possible to stop it. Okay, third thing, let us stop it. Now came the question, why is it happening? Why and how to stop? Why is it happening? How to stop? So these people said, sorry, we don't know why it is happening. Research is going on. How to stop? Sorry, we do not know how to stop. Research is going on. So imagine, such a proactive international convention has come into play. We don't even know why and how it is happening, but we are committing इसे रोकेंगे. भाई ये होना नहीं चाहिए. That's a very proactive one. भाई 1985 Vienna Convention, and all countries, the only convention to get a universal ratification. Universal ratification मतलब जो भी यहाँ चाय समोसा खा के गया, घर जाके उसने पास कर दिया, because इसमें कुछ करना ही नहीं था. Tell me, you don't have to do anything. You are just committing. हाँ जो भी होगा हम करेंगे, जो possible होगा करेंगे, थाली बजाएंगे, दिया जलाएंगे, सब करेंगे. करना तो कुछ है ही नहीं. So they said we will inform you. Remember, conventions are laws, but their real work will happen in COPs. So COPs will be meeting, and COPs will let you know. So two things. 70s में problem हुआ है. Who has come into it? Group of teachers and students. What are they doing? They are doing their PhD. They are doing research. And here the world is concerned, and world has this. These research people, take the story back to the research people. And they looked for samples in stratosphere, and they found that in stratosphere, apart from ozone, remember this is stratosphere, so what is there? Ozone, 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 ozone is there. They found some free radicals of chlorine, bromine. Now students from science background, you know chlorine and bromine belong to the halogen group. These halogens are highly reactive free radicals. They just require one more electron to get the stable configuration. If you don't know what is stable configuration electron, forget it. I am just saying they are highly reactive. They are highly reactive. The question is, how did they reach there? They should not be there. They should not be there. In fact, these PhD people don't know much, so they asked the chemistry people, yeah, please tell us what will chlorine and bromine do. The chemistry people were in a total theatrical mood. They said, let us tell you. See, this is oxygen, the husband. This is nascent oxygen, the wife, the loyal wife of oxygen. Husband and wife, in the presence of sunlight, give birth to a very healthy offspring called ozone, which protects us from ultraviolet radiations. This child sacrifices itself when UV rays falls on it, and the mama and papa, husband and wife, they again give birth, and it keeps on fluctuating. They said, yes, 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 we know this story. आगे बताओ. They said, सुनो यार, ये घर वाली है, यहीं पर एक आ जाए अगर बाहर वाली Cl. So if oxygen has to select घर वाली and बाहर वाली, oxygen selects this. Why? Because this is more reactive. So now the equation is changed. Oxygen, instead of going with O, will go for Cl and convert into chlorine, ClO, monoxide. ClO plus O. ठीक है यार, this is oxygen destroyed. What was this? Raw material for ozone, yes or no? Raw material for ozone destroyed by bahar wali. And remember, ghar wali is loyal, bahar wali is dangerous, unreliable, highly unstable. This molecule is not stable and soon it breaks back into Cl and O, and this is free once again. And remember, this attacks another O. So what will happen? Cl, if it is there, or bromine if it is there, it will start eating into oxygen, and this whole process of formation of ozone also is hampered. The story does not end here. ये बाहर वाली ओजोन को भी नहीं छोड़ेगी. O3 also has a very great affinity towards Cl, and O3 and Cl, they also come in contact and they form ClO plus O2, and ClO you know is not stable. ये bond ही stable नहीं है. So as a result, what happens? This also further. So can I say not only raw material but even finished product is also attacked. Who's doing this research? PhD students. They said, oh my God, this is dangerous. If halogens are there in the ozone layer, they will not only eat up oxygen, but they will also eat up ozone. Both of them are getting destroyed. As a result, naturally, which was thickening and thinning, natural plus halogen attack, what will it do? It is going to degrade the ozone. They said, what are these gases? So they said, अरे यार, CFC, chlorofluorocarbon. Question ये है कि ये बने कहाँ से? How did chlorine reach over there? These are man-made chemicals used for refrigeration, aerosols, fire extinguishers, refrigeration, aerosols, fire extinguishers, foam for construction activities and all those things, so foam and all that. So this is where these are uses. Chlorofluorocarbon. What are these chlorofluorocarbon? You've heard of what is it? CFC is there. HFC. What is HFC? Hydrofluorocarbon. Hydrofluorocarbon. PFC. What is it? Perfluorocarbon. CHC. Chlorohydrocarbon. If we add bromine to it instead of chlorine, this is called methyl bromide. Chloroform. Carbon tetrachloride. Carbon tetrachloride. So all these gases, ये सारी gases हैं. कौन पता कर रहे हैं? PhD students. If these gases, if these man-made chemicals, hydrofluorocarbon, perfluorocarbon, chlorohydrocarbons, methyl bromide, chloroform, carbon tetrachloride, if they are there, तो ये करेगा. यार PhD ने अपना काम कर दिया है और ये लोग क्या ढूंढ रहे थे? They were knowing why is it happening. Now they know why is it happening. How to stop? We don't know how to stop corona. So what have we done? We have done lockdown. So how to stop? We don't know how to stop. Let's do what? Ban these. Ban the production and use of it. Ban the production and use of it. But how do we do that? We have to have an international law. तो एक काम करो, बुलाओ लोगों को फिर से. बुला लिया. कहाँ पे बुलाया? Montreal. Montreal in 1987. 2 years after that, in Montreal has been called. और यहाँ जो law बनेगा, you know, पेरेंट लॉ को चेंज करने वाला लॉ क्या कहलाता है? प्रोटोकॉल. सो मॉन्ट्रियल प्रोटोकॉल. इसने क्या कहा? पता चल गया ओजोन डिप्लीशन इज ड्यू टू ODS. what should we do? Ban all ODS manufacture and use. What are ODS? Chlorofluorocarbon, methyl bromide and etc. We will write and we have written on this. ये मॉन्ट्रियल प्रोटोकॉल। और वो स्टूडेंट्स का क्या हुआ, पीएचडी वाले बच्चों का? भाई देखो मुझे नहीं पता इंडिया में पीएचडी में क्या मिलता है, उसके बाद आप बन जाते हैं प्रोफेसर हु डजंट नो मच बट फिर भी पढ़ाने का अधिकार रखता है, दैट्स वेरी सैड। इन लोगों को मिल गया नोबेल प्राइज, दैट्स अ बिग थिंग, दैट्स कॉल्ड प्योर रिसर्च। पेटेंट लो या नोबेल लो, ये नहीं कोचिंग के नोट्स ले रहे हो, बट ठीक है जो मिल रहा है वो तो लोगे ही पैसा। ओके, सो नो क्वेश्चंस कमिंग इन, लेट्स टॉक अबाउट दिस। ये पोल पर ही क्यों होता है? सिर्फ पोल ही नहीं, द प्रॉब्लम इज नॉट ओनली पोल, प्रॉब्लम इज द सीजन ऑल्सो। इट हैपेंस इन द स्प्रिंग सीजन, इन्हें नहीं पता। It happens only on the poles and it happens only on the spring season. Poles, spring season. People who do not know what is spring season, the season that has just come after winters. India में spring खत्म हो रहा है, अब क्या आ रहा है? Summer आ रहा है. So the season just after winters is called spring season. So why is it happening at the poles? So everyone pay attention. Very very important thing. ये दो वजह से हो रहा है. Two things. Get that? One is, I should say, geographic or atmospheric. And second is human activities. Let us understand this. This is a little bit of understanding, a little bit of technical part. So, ये अर्थ ले लेते हैं. And this is earth. This is earth, get that? Now this is equator, this is Arctic region and this is Antarctic region. So first of all we need chlorofluorocarbons. What are they? Those are man-made chemicals, man-made chemicals. So where are they being released? They are being released where people are living. किधर रह रहे हैं? या तो tropical area या temperate area. These are CC chlorofluorocarbons. Do we get that? Now the problem is not in these areas. The problem is at poles. So we need to understand first of all how did they go over there? How did they go to the poles? So I hope you remember the tricellular circulation model. This is the Hadley cell, remember? Hadley cell. This is the Ferrel cell. And this is the polar cell. Remember 3 cells? So what is happening is that whatever this C is there, if the C is released here, the C will go up in the upper atmosphere and it will come here. And this is how C has reached everywhere. So C may be anywhere, C may be released anywhere, but it can reach the whole world. Is everyone okay up to this point in time? What is, where is this circulation happening? If you remember, this circulation happens in the troposphere. So what is this line? This is tropopause. This is what? Tropopause, everyone. So in the tropopause, the chlorofluorocarbons are reaching everywhere. So will they, and where is ozone? This is ozone. Now this is why people get a Nobel Prize, by pure research lag rahi isme. First of all, chlorofluorocarbons can travel into the entire atmosphere, but the problem is they can travel only up to tropopause. Remember, troposphere is called the weather sphere. All weather events happen only in the troposphere. So where is the maximum? कहाँ तक पहुँच सकता है chlorofluorocarbon? Tropopause. It cannot reach the ozone. So question number 1, how will it impact the ozone? How will it impact the ओजोन? ये क्या है? ये आपका स्ट्रैटोपॉज। First of all, it should not impact the ozone. Ozone tak pahunchega hi nahi. So that's the problem. So bigger problem is, where are chlorofluorocarbons coming? They are coming from the tropical and temperate belt. They are taken to the poles, but ozone tak wo nahi jayega. Ozone apna hi natural thickening and thinning is happening. But on poles, something very interesting happens. Something very, very interesting happens. I want to tell you that in the winters, which season? Winter season. If you remember, this belt is the trade wind belt. This belt is the westerly belt. Westerlies become very strong. Westerlies become very strong in winter. Remember, I was talking about roaring furious 40s, roaring 50s and shrieking 60s. Very, very strong. So what happens is, the entire troposphere around the pole gets cut off because of these strong winds. Do we get that? Westerlies become very strong and they cut off the polar air mass from rest of world. Remember these three cells which were created, 1, 2, 3. What are they doing? They are circulating everywhere. But now what is happening? It is cut off. So whatever sea is there, where is it? It is trapped. But trapped where? In the troposphere. It is trapped only in the troposphere. Now comes a very, very interesting thing. Remember, this is what? This is troposphere. This is troposphere, and this is what? Stratosphere. I told you atmospheric phenomena happen only up to troposphere. There is a famous question, why aeroplane pilot flies above tropopause, and the answer is because above tropopause there is no cloud formation. Cloud formation happens only in the troposphere. Stratosphere doesn't have clouds. Absolutely okay. But I want to tell you, in the polar areas, this area becomes extremely cold. Extremely cold. And nitric acid based frozen clouds are created. What is created? On the poles. If the winter is very much like this, then what will happen? These are called SSC, Special Stratospheric Clouds. Not normally. किससे बने? नाइट्रिक एसिड से. SSC. Does everyone get that? In the winters, what is happening? These are trapped. Chlorofluorocarbons are trapped. Why are they trapped? Because the tricellular air circulation is stopped. Because it's very, very strong winds. It is very, very strong winds. If you remember, a polar front is created. Remember, a polar front is created in between these two. If you remember this is called the polar front when I was talking about the planetary circulation. In between these winds which are coming from 30 degrees and 60 degrees, when this air is forced to rise, a polar front. So this polar front does what? It acts as a wall. It acts as a wall around the polar area. Do we get that? So what has happened? Polar area has a wall all around it, and above that wall what has been created? Special clouds, stratospheric cloud. On the base of these clouds, because these clouds are heavy, on the base of these clouds in the winters the chlorofluorocarbon will stick. On the base of these clouds during the winter, the chlorofluorocarbons will stick. When the winter is over, when the winter is over, what will happen? Spring season will come, and these clouds will start rising because they are becoming, its temperature is increasing, they start rising and they dissolve, disappear. But in the process, what they have done, they have transferred these chlorofluorocarbons to the ozone layer. Once the chlorofluorocarbons reach the ozone layer, they will attack. Now remember, which season we were talking about? Winter. In winter, no sun, so no ozone formation. That means already the layer is thin. Already the layer is thin, and add to it you have the attack of chlorofluorocarbons. The layer is naturally thin in the winter, the ozone was not forming, and what you've done, added to it, you have introduced these chlorofluorocarbons. And I want to tell you, they have a long lifespan. Once a chlorine molecule reaches over there, it will stay there for a very, very long time, and it will destroy millions of ozone molecules and oxygen molecules. This is where already जब मार पड़ी हुई है, lack of photochemical reaction, the ozone has already thickened. On top of that, you add these chlorofluorocarbons, they attack it further, and a point might come that the entire ozone is missing. That is called ozone hole. Recently in February 2020, the ozone hole which was seen over the Arctic region was because of this abnormal winter which was experienced in the northern hemisphere. The colder the winter is, the chances of these stratospheric clouds, special stratospheric clouds being created, some books you will write them, you will see their name written as PSC rather than SSC, polar stratospheric clouds. They mean the same. Don't unnecessarily get into the jargon. Polar stratospheric cloud or special stratospheric cloud, not created normally because of that nitric acid over there. Frozen ones, they are created, and at the base of these clouds, the chlorofluorocarbons, they will stick, and as a result, the ozone is going to be impacted. So the layer is already thinned because of the winter, and add to it, you introduce those agents, radicals, and they will eat into it, and this is the normal layer. In the winters it was like this, and in the spring it goes further down, and a point might come that it vanishes because southern hemisphere has stronger westerlies. Remember, westerlies are always stronger than northern hemisphere. So it is more common that the ozone hole forms in the southern hemisphere because there the westerlies are able to block everything around the poles. That is also called a polar vortex. Students who attended my classes on jet stream or on environment, I talked about that circulation. The jet streams are around the pole. So jet streams are stopping the air from rest of the latitude to enter the polar areas. This is the polar area, and the westerlies also are so strong that they are not allowing the rest of the atmosphere to get mixed up and dilute those chlorofluorocarbons. So those chlorofluorocarbons have been taken to the top of the tropopause where the stratospheric clouds will form, especially when the winter is extremely cold, and they will stick to it. When the winter goes, these clouds will dissipate and vanish, but in the process they have taken those chlorofluorocarbons on top, and once that chlorine breaks, it is ready to attack the rest of it. So this is the science of it. This is why it happens only in poles. This is why it happens only in the spring season. It happened in the northern hemisphere this year. It happened in the northern hemisphere this year because, as I told you, scientists, if you read any book, they will say that it was extremely cold, and because of that stratospheric phenomena happened. So एक तो environment है, the formation of a polar vortex, formation of this polar front, very strong winds which will not allow mixing to happen. Second thing is, human beings are emitting these. So we had no control over these factors, that we can't stop the westerlies, we can't stop the polar vortex, we can't change the temperature of the winter. What we can manage is, we can manage stopping the release. So as a result, Montreal Protocol talked about stopping the release. So I have to end the class. It's been very long and my family is waiting. They also have a lot of things to do. I think it's the lunch time.